based video, we are going to explore the from guesswork to intelligence, design thinking in open loop and closed loop system in control system. So first of all, we want to know about what is control system. So we know that it is a system, the output is controlled by the desired input. Some real-time examples, we know that traffic light controller, water heater, and air conditioning unit, and etc. So now, Ashok, can you explain about what is from guesswork to intelligence?
So today we have two different scenarios. In the first scenario, imagine you're riding a bike. So now just twisting the accelerator without even looking at the speed, just hoping the speed is straight. So in this case, we call it as guessing. And the second scenario is imagine riding the same bike, but now you're looking at the speedometer and adjusting the speed again and again. So this is what we call as intelligence. So today we're going to understand how control systems moves from guessing to intelligent control systems by using closed loop and open loop systems with the help of design thinking.
So here comes our advertised part. In our daily life, we can expect systems to behave reliably. For example, fans, air conditioner, elevators, and vehicles. But in real world condition, constantly changes. Temperature varies, load changes, and disturbance occurs. So this is the key question where engineers face. That is, how can a system achieve despite output without a knowledge?
In definition part, we are going to see the control system engineering faces the main problem like reliability and accuracy. In normal operating systems, they are expected to produce the desired output, but the main challenge relies on where the desired output will be produced with high accuracy and correctness, even when changes and disturbance happens. Many systems start to produce without checking the result, but other systems produce while checking, monitoring their errors and correcting by themselves. Here comes two main control strategies: open loop control system and closed loop control systems.
Control system where when an output is given, the system processes and gives to the ideal path that's written to the open loop control system. So in this system, when the input is given to the controller, the signal is processed and the desired output is reached. And in this system, the input is only considered where the output, whether the desired output is reached is not considered. Because from the design thinking perspective, the system is completely based on assumption. And this is the first step towards control system where simplicity is being achieved with the cost of assumptions. So coming to the real world examples, whether it may be an electrical fan or a washing machine or a traffic light, everything performs a fixed operation. An operation is fixed and it performs action. And it does not adapt to the changing conditions. So here the system only depends upon the input and doesn't depend upon the output. Whether the output is desired or not, it doesn't care. It only cares about the input. When the input conditions are correct, it thinks that the output might be correct. So it's completely based on assumption.
So in closed loop system, there's a simple rule: never blindly trust on the output. So let's take an example of air conditioner system using closed loop system, using closed loop control system. So let's take 24 degrees Celsius as the input. In the AC, when you will input as 24 degrees Celsius, but in the room temperature is 26 degrees Celsius. It's showing an error. Then it will pass through the controller process, but you will get an error in the output. So as 24 degree and 26 degree is not matching, it will show an error until so it will show the error once again to the controller part. If if the 26 degree doesn't come down to 24 degrees Celsius, it will show error, and until that it won't work. So this is the basic system of closed loop system.
Arison, can you give a comparison about open loop and closed loop system with some parameters?
Sure, ma'am. In open loop system, it's really simple to build, but in closed loop, it's really tough because you need to add a feedback source. And if I see about the flexibility, closed loop system is really flexible and it can be used in many parts. If I give a comparison through examples, we can take an open loop system. We can take traffic signals because it works on timers. On 6 seconds, it shows red light, green light, and yellow light. And in closed loop system, there are multiple examples like a washing machine, or air conditioner, and the the cruise in the cars. The cruise would control the speed of the car. So these are the difference between open loop and closed loop.
Which output is better?
Yeah, better output is closed loop system.
The next part.
So finally coming to the conclusions. So the control systems are not just about equations and block diagrams. They are about designing the solutions for real world problems. So let's see some of the applications of control system. So as we see in the empathy part, in real life conditions are never constant. It's always changing, like the temperature changes and also there will be constant disturbances. So as we face all these changes, mostly modern control systems are made of closed loop systems. So for example, we can consider robotics uses robotics needs accuracy and electric vehicles need safety and also the air conditioning need maintenance. So in this the control loop systems gets the output and check and conditions the output. So however the open loop system is also still uses when needed, like when we need a low cost effective product and when it is a simple construction.
So from this presentation, we get to know the open loop system rely on guesswork while the closed loop system embody intelligence through feedback. So we have done a presentation in a DT based because design thinking helps the engineers to move from assumption to adaptations and control to confidence. Thank you.